So I was checking out this scope and I figured out something too. A bunch of these probes I got are no good. They're bad. So anyway, this is 120 volts, just one side of it. Um, and there's, I don't know, this level kind of seems a little funny. So it either goes through like that. I guess that's probably where it needs to be. And then you can look at it in different resolutions. That's going to be like 5 volts per division, 10, 20. And then we're looking at it 1 millisecond per division, 2, 3. Then you go all the way up to 10. Or really a lot. I'm not quite sure I've understood why we see the double waveform on this, but I guess when we're looking at this, it suddenly changes and it goes to one waveform. So I guess 5 milliseconds is 2 milliseconds. 2 is probably good. And then you have, different stuff you can adjust on here. The vernier and the level. Which seems to like to be in the middle. There's other stuff here for the trigger, which I'm not entirely sure what all of it does. In and out sort of is like invert. Slow, both in line, fast. I'll probably prefer it to be on that. Now, I never understood what TV is, but you see it on all the oscilloscopes. I don't know what SS is. So you get fast, you get slow. And then there's also this 10x. So that helps you look at a signal that's really big. This has also got this control is a little funky. Anyway, and then a trigger 1x, 10x, AC or DC. I would guess that I don't know what the X and Y is. Did you get that? And then so this is a really simple scope. You can plug in another channel here if you can get one of these. I forget what the company is because I can't read it, but it's a model 525. The company is in Melbourne, Australia. I guess it's BWD Electronics. There's something else though right here, and it says something else. But it's a 525. It's like somebody wore it off on purpose. I have no idea why. These unplug. They're kind of cool. So this is the vertical. So this is basically determine your bandwidth. This is a 50 megahertz unit. I don't do anything complicated, so actually I really like this because it works. It's really simple. There's not a lot of crap to it. It's not complicated like some of the Tektronix that I've had. I need to trace find. Ooh, good lord. It has a calibrator. I don't know what this output is. External input. I never understood what the external input for trigger amp is. The horizontal. I guess just some kind of signal goes in here and it bases off of that for the time base. But we have a few other things. It's just really simple. Not a lot to it. 1, 2, Alt, and then add whatever that is. So let's go ahead and look at this on this one here. Just see kind of we're at 2 volts per division, 2 milliseconds. Let's see what that looks like on here at 10x. We'll go ahead and undo this from the cord here. All right, so this one kind of gives you some other readings too. It's not real great for anything precise like frequency. I've tried to use it for that, and trust me, it's not very good. So, and this is definitely a very entry-level oscilloscope. I think they were $198 plus tax. I bought this like about 2 years ago. I did the firmware hack on this, so it's actually 150 megahertz. And I unlocked the external trigger generator out, and that part doesn't work anymore because of an accident we had. So you can download the firmware for the more expensive DSO 2C15. This one here is supposed to be 100 megahertz, no arbitrary waveform generator. Oh, well, you can tell it's enabled is it will turn on, but it doesn't work. The 5 volt 1 kilohertz still works. Anyway, so let's see what we're looking at. We're at 10 milliseconds. What did we have it on the other? We had it on 2 and 2 volts per division. This is I'm not sure. I don't know how to tell what it's actually. It's at 10 volts per division, and for some reason it's on DC coupling. I don't understand that part either. I'm really not that knowledgeable about oscilloscopes at all. I've only really ever used them to my advantage a few times ever. I look at a waveform like this to see, like on an inverter or something like that, or a generator, to see like what it looks like. So let's change our seconds per division to what we had. We're at 20 milliseconds. Okay. That's 2. That's what we were looking at on the other one. It looks pretty close. And then we were at how many volts? 5 volts. 2. Now, it's off the chart on this one. So I don't know if that means that the other one is just not accurate. Bandwidth, 20 megahertz. Probe. Okay, I don't know if that does anything. The probe is on 10x, but okay. Makes no difference. Doesn't change anything for this. So I'm wondering what the point of the 10x is. If it doesn't change anything. So we're looking at AC. It says 20 volts. Is that because we went 10x? I'm curious. That's 50 volts. per division. That doesn't seem right, does it? Because there's like 1, 2, 3. It'll be 50, 100, 150, like 60 or 70. 170 times 2. And it's actually probably about 180 when you can get 360 volts peak to peak. Now there's also the measure. Oh, I don't know where it went. So it lets us know that this is 129 volts AC RMS at 5960 hertz. And when I put my meter into the outlet, I definitely don't read that much. I think actually if we can look over here, I know that this particular unit over here agrees with my Fluke. It's a power conditioner. It shows 122. So 122. But anyway.
Workout resumed.
Lovely. Workout is resumed.
Workout paused.
This stupid phone. Anyway. So it looks the same as what I'm seeing on the other one, the shape you get. I don't know why I'm at 50 volts per division. That's 100 volts per division. I'm going to guess there must be some issue with the... that's our 2 volts. We can't even look at it. It's off the scale. So it'll say E. Now, here's the thing to note about this. We're at 100 volts per division. 50. 20. Now, this does have auto set. And you push auto set. And it will do this. So, it's actually accurate now, okay? This particular meter is not accurate unless you have absolutely perfect set. So if we go in and adjust this thing ourselves, we go like something different, the voltage will change usually. But anyway, I mean, this meter, it just depends on, or this oscilloscope, it depends on how you use it. You get erroneous results. So, like, I feel like I just use it as a visual, like, reference. It's not accurate, you know. So, I've had some problems using it to measure things. It's just like relative, you know. So you can make a baseline with it and then check to see what you've changed, you know. But anyway, I thought I would make a quick video because I was kind of surprised that the other thing worked. So I'm happy. I was going to get it out of here, but it works. So and it's less complicated than using this.